So this is the tension force, normal force. Another very common force is friction. Friction. When we have the contact surface, then there will be friction. For example, we have the book on the table like this one, right? If the table is horizontal, the book is on the table, then there is no friction. But if we start to move the book to the right, to the left, and so on, then there will be the friction. And I will show you an experiment. You can do this experiment by yourself by going to the internet and go to this site. Do you see the new screen from my computer?
Yes, I do see.
Yes, there is the big crate here, right? And we have the man. The man can be on the left or on the right. Okay. Let's say he tried to push on the crate so that he want to move the crate to the right of the screen. And here, if I click on the man and I try to push that, right? The crate is still in rest because the applied force is to the right, then the friction force is to the left, and the two forces are still balanced, right? So you can see if I increase the applied force, then the friction force is bigger too, right? And they always in opposite direction, right? I push that, then the crate is start to move. You see, if I push harder, then it move faster. And then if I stop, I don't act any force more, then the crate move away. Okay, let's start at the beginning. Okay, now I push on that, it's still in rest, and then I push. You can see the value of the force here, the is 76 Newton now, right? And then I increase that, increase, and then it start to move. Okay. Yeah. So if we draw the graph about the friction force, maybe we can get this kind of graph. I will show you the example here. Can you see the new screen?
Yes, I do.
Here we have a Dutch bin, right? If you apply the force to the right here, then there will be the friction force to the left. And if you increase the force, let's say at the beginning, the force is 0, and then we increase the magnitude of the force, the friction force is bigger, right? So it's always have the magnitude of the applied force or the external force. But at the end, or at this point, if you increase the forces, right, from this axis, you can see that the friction force will decrease, then remain constant here. So from here, at that point to the left, we have the friction force, but the object is still in rest. So we call it the static friction. Static friction. Here, you can see the static friction here, right? Then, if you apply the stronger force, then the beam will move. Then we have the kinetic friction. So we have two regions here. One is for the static, another one kinetic. How can we get the formula for that? The static friction is always equal to the applied force, but it has the maximum. So look at that, right? The maximum static friction will be the fraction here. Also, this is a factor multiplied with n. For the kinetic friction, you have Fk equal to mu k n. It means the kinetic friction will be constant for all of the motion and equal to a factor mu k and multiply with the normal force. So the normal force will be here and here. You see? And mu is called the coefficient of friction. So mu s is coefficient of static friction, mu k coefficient of kinetic friction. Okay? Normally, mu s is bigger than mu k, normally. But for some material, or exactly for some couple of material, mu s can be equal to mu k. I will show you the value of mu s and mu k here. You see, with the couple, rubber and concrete, then mu s is 1, mu k is null 0.8. Steel and steel, you have this pair value, right? But for example, when you have the Teflon, then the mu s and mu k will be the same. Okay, so you can see that. Then remember, the friction force can have now two times. One is mu k, Fk, kinetic friction, this one, and one is mu s, Fs, static friction. Okay, so that's it about the friction. Now we will come back to the motion of an object, and we have this example. Please read the text and try to understand the situation.